I hope you all caught that. A Shellhammer Child guest speaker. All right, lesson 25. Solving problems in two ways. Two ways is questionable. I'm going to focus on one particular way. So let's just go. All right, solve the following problem using an equation. All right, we're not going to go through the tape diagram. You guys don't have any history with the tape diagrams, so it's sort of difficult to present it for the first time with algebra. All right, so we're going to go straight to an equation. In a school choir, half the members were girls, which means the other half are boys. At the end of the year, 3 boys left the choir, and the ratio of boys to girls became 3 to 4. How many boys remained in the choir? So I can say that the number of boys initially, the number of boys can be B, and the number of girls can also be B, because they're equal. Half the number are girls, half the number are boys. And then at the end of the year, the number of boys is B minus 3, and the number of girls did not change. But we also know at the end of the year, the ratio of boys to girls became 3 to 4. So boys to girls was 3 to 4. Boys to girls. So we can just set up a basic ratio of B minus 3 over B, that's boys over girls, equals the ratio boys over girls. Then honestly, whenever I have an equation with an equal sign, just a simple equation on the left and simple on the right, I just cross multiply, or I multiply down, however you want to say it. 4 times B minus 3 equals 3 times B. Coming up here to work, I have 3B equals, distribute that 4B minus 12. Subtract 3B from both sides because I like to keep things positive. Add 12 to both sides. So B equals 12. So the number of boys is 12 at the end of the year, which means, just B equals 12. Duh. Just B equals 12. You go back to the beginning at the end of the year. Boys actually equals 12 minus 3, which is 9, and girls, which is B. I don't know why I crossed that L. Girls is 12. So we have our answer. The number of boys remaining is 9, and the number of girls is 12. This problem is actually from your problem set, so you might want to grab a blank sheet of paper to take notes because you are going to be responsible to know this one. The second problem that was in the classwork wasn't my favorite. I thought it was very unclear, difficult to talk about, so I went straight for a problem set one. Okay, so let's go ahead and talk about this one. And again, we're not using a tape diagram. So solve the following problem by setting up an equation. For each, give your opinion on which solution method was easier. Can you see the connections between the two methods? What does each unit in the tape diagram stand for? Blah, blah, blah. Sorry, that was negative. But I'm cracking myself up. Okay, so 16 years from now, Pia's age will be twice her age 12 years ago. Find her present age. Some people grew up playing these age puzzles, and they just found them as puzzles. We actually use them as algebra. So we can say that Pia's age now And we're just going to say is P years old. Reread the 16 years from now, Pia's age will be twice her age 12 years ago. So if Pia's age now is P. So 16 years from now is P plus 16. So 16 years from now, Pia's age will be twice her age 12 years ago. When I say something is twice, it's multiplication, which is why I did that. And 12 years ago is subtraction, which is why I did that. 16 years from now is addition, which is why I did that. Now we can just solve. The hardest part about these problems is setting up the equations. The easier part is definitely solving. I'm going to distribute that too. Subtract 16. I get negative 40. Oh, I don't know why I subtracted 16. That's backwards. So let's not do that because I don't like making things negative. I'm going to add 24 now. 40 and subtract P. So P equals 40, which means Pia is 40 years old. And we can check it. 40 plus 16 is equal to 2 times 40 minus 12. 56 equals 56. Yahoo! I'm also going to do letter C, so you are going to do B and D. I'm going to do C. This is another age one, but a little bit different. So again, the instructions are the same. I just cut the problem out. So 5 years from now, the sum of the ages of a woman and her daughter will be 40 years. The difference in their present age is 20 years. How old is her daughter now? So we need a variable, right? And this is the hard part. So let's just say that her daughter's age now is D, years old. So what's that mean about the woman? The woman's age now, it says here, is the difference in their present age now is 24 years. So I can say D plus 24 years old. Cool. Now, 5 years from now, the sum of the ages of a woman and her daughter will be 40 years. So sum 40 years. So 5 years from now, how old's her daughter going to be? 5 years from now, her daughter is going to be today's age plus 5. 5 years from now, the woman is going to be today's age plus 5. And the sum of those two ages is 40. I know, and once you get it written down, you're like, oh, dude, that's so easy. Let's collect some like terms. I have D and D is 2D. 5 plus 5 is 10, plus 24 is 34. Subtract 34 from both sides, I get 6. So D equals 3. So that means the daughter is 3 years old. And the woman, I don't know why we're not calling her a mom, is 27 years old. We can check that. In 5 years, the daughter is going to be 3 plus 5 is 8. And the woman's going to be 27 plus 5 is 32, which you add together and you do in fact get 40. All right, I'm going to try 2 more of your problems, and you're going to do the other 2 for practice. All right, so I'm doing B and I think D. You're going to do A and C. This is also a really common problem that you'll need to be able to do quite easily. I see these on the ACT when I practice with students, not on my own. Find 2 consecutive even numbers such that the sum of the smaller number is twice the greater number, and twice the greater number is 100. So the first thing we have to do when we see a problem like this is come up with a variable for one of them. So we always say the first number is going to be x with problems like this. Always. Now the second number, when we say that they're even, if the first number is x, the second number needs to be an even number bigger than x. So you think about it. If the first number was 2, the second number is going to be 4. If the first number is 6, the second number is going to be 8 because they're consecutive. They're one right after another, and they're both even. So if the first number is 2 and the second number is 4, how did I get that with an equation? I say it's the first number plus 2. Now let's read the problem again. Find 2 consecutive even numbers such that the sum of the smaller number and twice the greater number is 100. So the sum of the smaller number and twice the greater number is 100. I know that's the hard part, and I just made it look so easy, but it's okay. You guys can practice and get it. Now I'm going to distribute this. Collect like terms. Oops. 3x plus 4 equals 100. Subtract 4 from both sides is 96 equals 3x. Divide by 3, x equals 32. And if you think about it, if the first number was 32, the second number is 34, I can say we're going to do twice this is 68 plus 32 is in fact 100. We got it. Woohoo! One more. The product of 2 consecutive whole numbers is less than the sum of the square of the smaller number and 13. All right, let's just piece by piece. Don't let it confuse you when you read it. We just talked about this, where I say the first number is going to be x. What do we call the second number? So here I just have 2 consecutive whole numbers. So if the first number was 1, the second number is 2. If the first number was 10, the second number is 11, etc. So if the first number is x, the second number is x plus 1. Now the equation, the product, which is multiplication, of 2 consecutive whole numbers, let's pause there, the product of 2 consecutive whole numbers is less than the sum of the square of the smaller number and 13. So the sum of the square of the smaller number and 13. Not that bad, right? All right, so distribute the left. X squared plus x is less than x squared plus 13. I'm so excited that these x squareds cancel out because it makes life easier. X is less than 13. Was it really that easy? All right, so let's check it. X is less than 13, but it has to be a whole number. So I have to go above 0, right? I can be equal to 0, so it has to be 0 or bigger and less than 13. So let's test it. If x was 0, I've got 0 times 0 plus 1 is 1 is less than 0 squared plus 13. 0 is less than 13. Yep. Let's try 3. 3 times 4 is less than 3 squared plus 13. So I've got 12 is less than, this is 9 plus 13 is 22. Yep. Let's try 14 just to be safe. Should 14 work? No, in fact, it shouldn't. 14 times 15 less than 14 squared plus 13. So 14 squared is 196 plus 13 is 209. 14 times 15 is 210. It is false. I shouldn't put an X there. It's false. So here is my answer. Sweet. That's all I got. You guys have 4 problems to do for practice, and it's going to be fantastic. Good work.